Okay, so we've got an equivalent resistance, I think 1.85 ohms. So part B, calculate the current through the battery. Pardon me, V equals IR, so there's 4.5 volts. I have a resistance of 1.85 ohms. And I'm getting 2.43 amps. By this point, these two things need to be like second nature to you, right? And if not, I would encourage you to talk to me when I'm here tomorrow or Thursday, or if you want even to come in tomorrow and get an SRT pass from me, that would probably be a good idea. Because at this point, we've done things like this far enough that I'm going to assume that you know how to do that. If you don't, it's not necessarily a problem, but we do need to address that. All right. Now part C, find the voltage and current through the 4 ohm resistor. Okay, so if we look at the 4 ohm resistor maybe here, we have to look at the question is it on the same branch as the battery, or is it connected directly to the battery? And if you look here, it's actually connected directly to the battery. So that side goes to one end of the battery, and this side goes to the other end of the battery. That means that I can say the voltage of this resistor is the whole voltage of the battery, right? And then to find the current, I'm doing V equals IR. So my voltage I just said is 4.5. This is a 4 ohm resistor. So 1.125 amps. And again, we can check. This should be a portion of that. It should not be the whole thing, because again, the current coming out of there, some of the current went this way, some of the current, 1.125 amps of it, went this way, and some of the current went that way. All right. Now, I am not going to do number 3 with you. I'm going to have this up pause it for a little bit. In a little bit, I will give you the answers to number 3, but I will not do it with you because I'd like you to try one by yourself. All right, so hopefully now we're back. So you've had a chance to try number 3. I'm just gonna give you the answers real quick. I'm not gonna work it out directly for you. I want you to have an opportunity to do this, but I got the equivalent resistance of this whole thing to be 6.72 ohms. Okay, which means that the equivalent current is going to be 1.34 ohms, or sorry, 1.34 amps. And I will do part C with you, because again, I just want to make sure to come through this. Find the voltage and current through the 4 ohm resistor. Well, what do I know about this? Can I say that this 4 ohm resistor is connected directly to the battery? No, I can't, because even though this side's connected to the battery, this side is not. So it does not have the same voltage as the battery. What does it have the same as the battery? Well, if I look though, it is on the same branch as the battery. Since it's on the same branch of the battery, it has to have the same current as the battery. So it still has to have the same current. Pardon me, not the same voltage. So then I can do V equals IR. And we have a 4 ohm resistor, so 1.34 amps times 4 ohm resistor is 5.36 volts. And finally, I'm going to give you a little bit of time here to work on question number 4 and 5. So these are they're more thinking questions. There's nothing you have to calculate. You just got to think through what's going to happen here. So I'm going to give you a few minutes. I'm going to ask the sub to pause this again for a couple minutes. All right, and hopefully we're back. So let's go through this. Consider this circuit. What happens if bulb A breaks? Well, if bulb A breaks, I'm not going to write all this down, but you can write it down. Will B be on? No, there is no complete circuit through B. Will C and D be on? Well, yes, because there's still a complete circuit through C and it's a complete circuit through D. I guess I will write it down. So B will turn off because there's no more complete circuit through B. But C and D will stay on because they are still connected to both sides of the battery, so there's still a complete circuit. If bulb A is taken out and replaced with a wire, will bulb B get brighter, dimmer, or have no change in brightness? How about bulbs C and D? All right, well, let's look at D. Well, all of a sudden I don't have as much, if this becomes a wire, right? All of a sudden I don't have as much resistance. So B should get brighter because there's less resistance. What about C and D? Have I done anything to them? No. C and D still have the same voltage. I haven't changed the voltage through C and D because they're both connected to the battery. So they still have the same brightness. All right, number 5. Before the switch is turned on, which bulbs are lit? Well, there's a complete circuit through A, but there is not a complete circuit through B, so only A. What will happen to the brightness when I close this? Well, A is going to have the same voltage, so A will have the same brightness. A will have the same brightness because it has the same voltage. B will now turn on though, right? So those are just good mind-bending questions. But again, you got a quiz coming up on Friday. What do you have to be able to do for the quiz? Again, you have to be able to tell me what happens to, like we set up here, you have to be able to tell me what happens to, oops, not that one. What happens to bulbs in series and parallel, and then you'll be given one problem like this. As a matter of fact, your quiz will look very similar to the page front of this. You'll have a different circuit there, and the question is not going to be open, comparing or contrast. It's going to be specifically talking about adding resistors in parallel and series. That's what your quiz will be like on Friday. And then, like I said, tomorrow, though, we will be doing a lab. All right. With your remaining time, you can go ahead and work on your final exam review packet. And again, please stay working and be on your best behavior. And I will see you next class.